Welcome everyone. Today we are going to explore data engineering on Microsoft Azure. This is a fundamental content for everyone preparing for DP-203 certification or looking to build a career in data engineering. By end of this video, you will understand what data engineering is, how Azure provides tools for it, and get a hands-on familiarity with the key services like Azure Data Lake Storage and Azure Synapse Analytics. So in this video, we are going to cover three main topics. And the first one is the introduction to the data engineering on Azure, which will help you to understand what data engineering do and how the Azure ecosystem works. And the second concept is about Azure Data Lake Storage Gen 2, where it acts as a foundation for storing analytical data at scale. And the third topic is about Azure Synapse Analytics. It is the main unified analytic platform that brings everything together. So let's dive in it. So the first concept, as I mentioned, it's about introduction to the data engineering on Azure. So first we need to understand why the particular data engineering fundamentals is more important and what exactly data engineering is and how it is important in the today's data driven world. So data engineering is all about building the infrastructure and the system that makes data usable for analysis. Think of data engineers as the architects and plumbers of the data world. They build the pipelines that move data from where it's created to where it needs to be analyzed. So coming for the types of data, we have structured data, semi-structured data, and also unstructured data. Coming for the structured data, this is the data that fits neatly into the tables with rows and columns, like what you'd find in a traditional database. Think customer records, transactional logs, or any inventory tables. Coming for the semi-structured data, this has an organizations but doesn't fit perfectly into table. So like JSON files, XML documents, log files fall into these categories. Coming for the unstructured data, image, videos, audio files, free-form text documents, all these come under this particular unstructured data. Now, coming for the core data operations, where it has around three operations, which are integration, transformation, and consolidation. Integration is all about connecting to multiple data sources and bringing data together. You might pull from an on-premise SQL server, a cloud API, an IoT services, or any flat files. Coming with the transformation, cleaning, reshaping, enriching the data all comes under the transformation. Converting currencies, standardizing the data formats, joining datasets together also makes the transformation data operations doable. Next comes with the consolidation. Consolidation is nothing but bringing everything into a centralized analytical solution where analyst and data scientist can access it, right? So these are the main data operations that we do in the data engineering. And coming for the languages which a data engineer uses is we have around five forms of backbone of a modern data, right? So coming for the languages, it's all about two main languages, which is SQL and Python. SQL is the universal language for querying data, and Python gives you flexibility for complex transformation. Other languages like Scala, Java, and .NET are also used depending upon the platform we use. So the next topic is about the data engineering concepts. Let me introduce five concepts that form the backbone of the modern data engineering. The first is about the operational versus the analytical data. Operational data is a transactional. It it's about the application usage of day to day. Think of it like a bank's transaction system. It can be in a e-commerce shopping cart or even a CRM. These systems are optimized for quick reads and writes of individual records. Coming for the analytical data, it's optimized for analysis and reporting. It's often aggregated, historical, and organized to answer business operations like what were the sales trends of over the past 3 years. So all those data comes under the analytical data. Now coming for the streaming data, real time continuous data feeds or nothing but the streaming data. We can take an example of IoT sensors sending temperature readings every seconds and social media feeds or even financial market data. Data engineer need to build system that can handle never-ending flow of information. Coming for the data pipelines, these are the orchestrated workflows that move and transform data. They implement ETL, which stands for extract, transform, and load, or also we can term this as ELT, which is extract, load, and transform patterns. A pipeline might extract data from 10 different sources, apply transformation, and load it into a data warehouse, and all on the scheduled basis. Now, let's come with the data lake. Data lake stores the data in its raw, native format using files. It's built for massive scalability and can hold structured, semi-structured, and unstructured data all in one place. Think of it as a huge reservoir which you dump all your data before deciding exactly what you use it for. Next comes for the data warehouse. A data warehouse stores analytical data in a relational database format. The format is typically organized using a star schema with a fact table surrounded by the dimensional table. This structure is optimized for analytical queries and reporting. It's about the data engineering in Azure. The slide is about a big picture of how the data engineering concepts are pictured. So now let's see how the Azure provides tools for each part of a data engineering workflow. You can think of like from the left to right flow. Starting from the left side, which is the operational data and ingestion. This is where the data originates. The applications, databases, IoT devices generate these data. Azure Data Factory orchestrates data movement and pipelines. Azure Stream Analytics handles the real-time stream analytics. Azure Event Hub injects massive stream of events. Coming for the center, which has the data storage and processing, this is core of what we'll cover. The Azure Data Lake Storage Gen 2, which stores file in a distributed, scalable file system. And we have the Azure Synapse Analytics, which is a unified platform that combines data warehousing, Spark processing, and data ingestion. And also we have the Azure Databricks, which is also another option for a Spark-based analytics. On the right side, we have modeling and visualization. We have the Power BI, which creates the dashboards and reports for business users. As a data engineer, we focus primarily on the left and the center section, getting the data in, making it ready for analysis. There is another course which is DP-500 certification, which covers about the Power BI and enterprise modeling side in more depth. Next session is about the Azure Data Lake Storage Gen 2. So here we will understand about what is Azure Storage Gen 2 and the foundational storage layer for modern data lakes in Azure. So whenever we say Azure Data Lake Gen 2, its short form is about ADL Gen 2. So it's Microsoft solution for enterprise data lakes in cloud. There are some key features which the ADL has. The first feature is about HDFS capability. So HDFS stands for Hadoop Distributed File System. It's a file system standard used by big data technologies like Hadoop, Spark, and many others. By being a Hadoop compatibility, ADLS Gen 2 works seamlessly with Azure Synapse Analytics, Azure HD Insight, and Azure Databricks. Coming for the next feature, where it has a flexible security, you can think it of like you can set a permission at both the folder and the file level. This is crucial for the enterprise where different teams need access to different dataset. And also it's built on Azure storage, which means you get high performance optimized for analytical workloads and also massive scalability, which helps us to handle petabytes of data and also the data redundancy, which will help in building a replicated protects your data against hardware failures. Think of ADLS Gen 2 as a hard drive for your analytics, but one that can scale infinitely and it's accessible by all the major processing engines. Now we have a difference between ADL Gen 2 and Azure Blob Storage. So this is commonly confusing topics. So let me clarify how it works. Here is something that confuses, right? So it's actually a feature you enable on top of blob storage. That's nothing but ADLS Gen 2. Standard blob storage, which you can see that in the left side, uses a flat namespace. You can organize blob storage using slashes in their names, giving the appearance of folder. But here is the catch. Like, let's say if the folder 1 isn't really a folder, it's just a part of blob's name. You cannot perform folder level operations like setting permissions on all files in a folder at once. While coming on the other side, which is the ADLS Gen 2, enables by turning on hierarchical namespace when creating your storage accounts. Now, the folders are real objects. Directories and files exist as actual entities. You can perform folder level operations, set permissions on the folder, rename the folder, and etc. Compatible with big data compatible analytics systems like Hadoop, Databricks, and also Synapse Analytics. The key takeaway here is if you're building a data lake for analytics, always enable hierarchical namespace. It's a difference between organizing files and having a real file system. And of course, the next slide is about the knowledge check, which you can refer it and try to answer the questions. And you can see the correct options for it. And here comes the next slide, which is about the introduction to the Azure Synapse Analytics. So what is Azure Synapse Analytics? Azure Synapse Analytics is a cloud platform that combines multiple capabilities that use to separate a service. The core capabilities here are large scale data warehousing. So we built enterprise data warehouses that can handle massive data sets, advanced analytics which can run complex analytical queries and machine learning workloads. And also we have the data exploration and discovery part which helps us to explore raw data without moving it. And also we have this real-time analytics which helps us to analyze streaming data as it arrives. Coming for the data integration, we build and orchestrate the data pipelines. Coming for the integrated analytics, everything works together in one unified experience. So this interface, you'll use it as Azure Synapse Studios, which is a web-based environment where you manage all your capabilities from one place. When you create a Synapse workspace, Azure automatically provisions the underlying resource you need, a storage account and compute resource, etc. So next, coming for the work files in the data lake, everyone, every Synapse Analytics workspace comes with a default data lake. This is an ADLS Gen 2 container that automatically created and linked to your workspace. You can also connect to additional data lake using linked services. This lets you work with the data stored in a multiple storage accounts. A typical data engineering workflow looks like this: ingest raw data files into a data lake, process and transform those files using Spark or SQL, then load the refined data into analytical stores like our data warehouse, serve that data to reports and dashboards. So the data lake is your central staging ground for all this work. Next comes with the ETL patterns. It helps us to implement and extract, transform, load, or extract, load, transform workflows. Coming for the integration part, which helps us to connect to hundreds of data sources and destinations. Pipelines are how you automate a repetitive data engineering task. Instead of manually running the script, you define pipelines that execute on schedules or in response to trigger. We will explore pipeline much more in the later courses.